Guys, welcome back, and so let's get into it. And so we're asked to answer the following. It says, suppose S and T are sets. Under what conditions is the union of S and T equal to T? So if the union of S and T is equal to T, it can only mean one thing. It would mean that all of S is within T. Wow, so what do you mean? It would have to mean that. It would have to mean that S is a subset of T. So what does it look like? Well, let's find out. So as you can see from our example here, we're saying that S is equal to 2 and 2 and T is equal to 1 and 2. And you'll find that S, let me just do one more thing. Right. So yeah, so as you can see, T contains S. T is not equal to S because they don't have the same quantity, okay, and they don't have the same elements. However, when we look at the union, wait, let me just do this, so this is S and this is T. So you can see the quantity is different and the elements are different, but the union of it is 1 and 2, and as you can see, the union of S union T is the same as T, and therefore these are the conditions. So second thing they ask us is, suppose that X and Y are sets, that the intersection of X and Y is equal to X. So it's going to be more or less around the same thing, in the sense that if, remember, it's equal to X, that means if it's an intersection and it equals to X, that means all of X should be inside of Y. Let's have a look. Yep, there we go. And finally, it says, suppose X and Y are sets, suppose if A and B are sets, that the intersection of A and B is equal to the union of A and B, what can be deduced? It's simple. If what we know already is, if these two are equal to each other, the union and the intersection, A is a subset of B and B is a subset of A, which would imply that both are equal to each other. And therefore, to give you an illustration, this is exactly what we mean. Because the only time the intersection and the union will be equal to each other is when A is equal to B, the exact quantity and the exact same elements. All right, so let's move up. Okay, I hope you went over your properties and all of that. Okay, so we're going to do this section. So first of all, I'm going to go through this really quick. The intersection of X and X. Remember, X divided by X intersection X, that's going to be X. We remember that from our properties, if you recall. So let's check. The union of X and X, that's going to be X, right? I'm just going to start to delete the stars, right? So next we have the union of something and nothing, X and nothing. When it's a union, the union, remember, it's one set of something and the union of it, not the intersection. Therefore, it is X. All right. Let's do the next one. So we have D, the intersection of something and everything. That would be X. Because it's an intersection, it's the common elements, okay? So with E, the intersection of x and, so this is a key one, something to take note of, is that it has this apostrophe. And when it has an apostrophe and it's a union, I want you to always think of this. All right, when you see the apostrophe and the union side, this variable actually stands for everything. Okay, so it's the union of x and everything, and that would be everything. Okay, so let's do the next one. We're at f. So once you see the apostrophe, it means the opposite. Okay, and the opposite of everything would be nothing. All right, yeah, so nothing. And then we have G. So at G, it says, okay, I'll see you in the next video. We're going over time.